We're going to begin our discussion with angles of a polygon today. This is section 8.1, and we're starting with a regular heptagon. Remember that regular means that all of the sides are congruent and all of the angles are congruent, and heptagon means you have 7 sides. So you want to remember when it's regular, and I'm putting these markings in just as a reminder, though you won't put those in every time. And when we talk about a regular polygon, all the sides are congruent and all of the angles are congruent. Now we want to find the sum of the interior angles. And remember from our investigation that we found that the sum is equal to n minus 2 times 180, where n equals the number of sides. So we have 7 minus 2 times 180, which gives us 5 times 180, which gives us 900. Now, if you remember when we developed this formula, we found n minus 2 was the relationship that if I made all the diagonals I could from one vertex, that I would get 2 less triangles in that figure than there are number of sides. And since the angles of a triangle always add up to 180, then I can take the number of triangles times 180 to get the sum of all of the angles in that polygon. That's why it's n minus 2. Now if I want to find the measure of one of the angles, since all of the angles are equal, you take the sum and divide it by the number of angles, which is 7, the same as the number of sides. So that's how I get 128.57 degrees. We also investigated the sum of the exterior angles and found that no matter what shape the polygon is, no matter how many sides there were, that the sum was always going to be 360 degrees. So just like finding one interior angle in a regular polygon, I divided by the number of angles. I can do the same thing for an exterior angle. I take the sum, 360, divide it by the number of exterior angles, 1 at each side, which is 7 here to get 51.4 degrees. In the next problem, we want to find the number of sides of this polygon, and we're given that the measure of an interior angle is 135 degrees. So you take the sum, you divide it by how many angles you have, and that's going to equal your interior angle. So the sum, we don't know how many sides we are, so we have to call the sum n minus 2 times 180, and we'll divide it by n because that's how many angles we have. Now, I can't solve for n when it's in my denominator, so I'm going to multiply it by both sides. So now I'm going to have 135n equals, distribute your 180, so now I'm going to have 180n minus 360. Go ahead and can get your like terms together. So I'm going to subtract 180 from both sides. So now I'm going to get negative 45n equals negative 360. Don't forget about that minus hanging out in front of that 360. When we divide, the two negatives shouldn't bother us because they're going to reduce to a positive, since a negative divided by a negative is a positive. And that gives me n equals 8. That means there's 8 sides in this polygon, which means it's an octagon. Now when you're writing out your answers, you need to remember to answer the question. So notice here I'm writing there are 8 sides in the polygon because that was the question I was asking. Saying n equals 8 isn't enough. N equals 8. You made up the n in your problem. You need to actually answer the question. In this one, we're going to find the measure of each interior angle, and I've already started making my sum out because I know that I have 4 sides here, which means the sum will be 4 minus 2 times 180. 2 times 180 actually gives me 360. So anytime we have a quadrilateral, the sum of all the angles will be 360. Don't make the mistake of always writing the sum to be 360 for every polygon. Students like to do that. You have to find the sum by taking n minus 2 times 180. So next thing we do is take all those angles of that quadrilateral and add them together to get 360. I'm going to simplify this just by, instead of writing 11x plus 4 plus 11x plus 4, I have 2 of them, so I'll write 2 times 11x plus 4. I have 2 5x's, so I'll add those together to get 360. I'm distributing now in number 3 to finish solving that problem. So 22x plus 8 plus 10x equals 360. I will then combine my like terms to get 32x plus 8 equals 360. We want to subtract 8 from both sides. I'm not going to show that here, but please remember that's what we're doing, subtracting, because I have a plus 8 there. When I subtract 8, I get 352, and then I will divide both sides by 32 to get x equals 11. You can now substitute x equals 11 into each of your angles. So I only have 2 different expressions, 11x plus 4, so I plugged in 11 there to get 121 plus 4, which gives us 125. And then I have 5 times 11, which gives me 55. So I have two angles that are 125, two angles that are 55. You can write your answer that way, or you can just write them out as I am here, that the angle measures are 125, and then I'm going around from just in a clockwise manner, 55, 125, and 55 degrees. In the next problem, let's do one more. This time I have a pentagon. There's 5 sides, so we want to find the measure of each interior angle, so we've got to find the sum and then take all of those expressions and add them up to get the sum for a pentagon. And the sum for a pentagon is 5 minus 2 times 180, which is 3 times 180, which is 540 degrees. Take all of your angles, x plus 20 plus x plus 5 plus x minus 5 plus x plus 10, and add them up to get 540 degrees. Now this can be tedious writing this long of a statement, so you can feel free when you're doing this work to actually just add all the x's up in your head and then add all of the constants up in your head. And if you did that, you would just get 5x plus 30 equals 540. You can continue solving that algebraically. Subtract your 30 from both sides, you get 5x equals 510. Divide both sides by 5 and you get x equals 102. And now you can plug 102 into each and every expression for every angle, starting with the x. The angles are 102. Then take that 102 into the x plus 20, which gives you 122 degrees. Then take 102 plus 5 to give you 107. Then 102 minus 5 to get 97. And then 102 plus 10 to get 112 degrees. All right, that's going to wrap it up for just giving you some examples on how to use the sum of the interior angles and exterior angles of a polygon. Feel free to keep watching this video as you need to give you some help.